two problems. Number 7, I see two parentheses, and they each have squares and ones. That's a clue to me that that's probably a Pythagorean identity. So let's look for the one that says tangent squared plus 1. You may have to rearrange something.
Secant squared.
It is secant squared? Okay, so that's secant squared of x for the first one. And cosine squared minus 1, if it was the other way around, would have been sine squared.
Yeah.
So instead of being sine squared, it's...
No, it's 1 minus sine squared, which is cosine.
No. If we normally have sine squared of x plus cosine squared of x equals 1, what is going to be the cosine squared minus 1 if I rearrange that equation to look like I see the second parentheses? Negative sine squared. All you have to do is rearrange the purple up above and you will see it. So I have two parentheses. The first one is secant squared, and the second one is negative sine squared. So first parentheses, second parentheses. Now knowing that, what I see is that the secant squared can be written in a different way. I could rewrite that if I want to as the same thing as 1 over cosine squared, because they're reciprocal functions. And then negative sine squared, I'm going to write down as negative sine squared. And I don't write it down usually, but I know that that's really over 1. So that when I simplify that by putting them on top of each other, I see negative sine squared of x over cosine squared of x, which then, of course, I know is the same thing as negative tangent squared of x, and you can see that they're now the same. I want you to try number 8, and I'm going to give you 4 minutes. Go. So I'm going to do the conjugate. So I'm going with the gray method.
What the?
Function. So if we work with the left side like Gray did, and we use the conjugate on the top, we see cosine x plus sine x cosine x. And down below, because we're multiplying the difference, or we're multiplying two conjugates, we always get the difference of two squares. So on the bottom I will see 1 minus sine squared. Ooh, look at the denominator.
Cosine.
That's a cosine squared. Very good. That's a cosine squared. So now I'm going to write down on the bottom that I have cosine squared x. And on the top, I notice that both terms have a cosine. So maybe I shouldn't even multiply that out. Maybe I'm just going to write it down as cosine x times, again, like what I had earlier, 1 plus the sine x. Why would I do that? Well, as I look at this thing, what I notice is that down below that cosine is really like saying cosine times cosine. That's what cosine squared is. And in the top, I have the cosine times 1 plus sine. And what you should notice is that top and bottom, the cosines reduce. So that's kind of nice. And then I see a heart. So I break it apart. And I get 1 over the cosine plus sine over the cosine, which, if we simplify, we know is the secant of x plus the tangent of x, which we can see is the same. So the big idea for today is we already know how to do these things. The great news is there's an equal sign, so we know where we're going. You can work with the left, you can work with the right, you can work with both. Make sure you show all the steps on the test. I'll know, because I'll be following your work. If your steps are wrong, you don't get credit. These are usually worth about 5 points apiece.